So dear students, in this video we are going to see the next topic of the last lecture, that is inserting a new node after a specified node. Earlier we have seen how to insert a new node in the beginning. Now we are seeing inserting a new node after a specified node. Now suppose we have 4 or 5 nodes in the list. We will take 4 nodes as example. That will be easy for understanding. Suppose we have 4 nodes in the list and we wish to insert a node after second node in the linked list. That means you can visualize the linked list having 4 nodes. One node, second node. I will keep a gap between second and third node and fourth node. Right. This is the fourth node whose last link will be null. Third will be pointing to the fourth, and I will make a line like this. This is second node pointing to the third node, and first node pointing to the second node, and this is your head. Okay, ठीक है. Now what you have to do? You have to insert a new node here, right? You have to insert a new node here. Now you will be given a pointer called as previous node. Now this is the previous node, right? The name of the pointer is also previous node because it is the previous node of new node. Now what you have to do? You have to make a link like this. This is your new node. So what is this node? This node is nothing but next of previous node, right? This is the next of previous node. This stores the address of this node. Yes. So previous of next will be, it will be step like this, right? Is equal to, here it will be previous of next, and on the left side it will be next of new node, right? Here it will be next of new node, right? After that what you have to do? You have to make a link like this. This link can be made very easily by writing a statement called as previous of next is equal to new node. This much effort you have to take in order to insert a new node after a specified node. Now what happens? The following are the 5 steps to do this, right? In which the very first step is to check if the given previous node is null or not. What happens if the previous node is null? Then it is a case of inserting a new node in the beginning, which we have seen earlier. That's why we will just print a message that previous node cannot be null. Okay. Then in second step what we do? We allocate a new node, right? This is very easy to understand. With the help of malloc you can allocate a new node. Third step is to put the data. This is also easy. Now fourth step is to make the previous of next, right, is equal to, on the left side, new node of next. What happens due to this? Due to this, the newly created node's next pointer will point to the node which is next to previous node, This I explain you diagrammatically. So this step is very easy. Last step is only previous of next. Previous nodes next will be pointing to new node. Previous of next node will be pointing to new node. So this is about the algorithm of inserting a new node after a specified node. Now we will see C programs function on this. Now on your screen you are seeing a C program function whose name is insert after, in which I have written the algorithm in comment and I have written C statements for that particular algorithm. The very first statement is check if previous node is null or not. For that I have to take the help of if previous node is equal to null. If this is the case, then I have to print a message the given previous node cannot be null. This you have to check because we are inserting a node after a specified node. Allocate a new node. This is very easy, which I have already explained in the algorithm, and after that you have to go for third step and then fourth step and then fifth step. Okay, the only difference between algorithm and C language is that in algorithm you are not writing this statement. Okay, you are not writing this statement. What is this statement? This statement is function return type void, then function name insert after, and then passing the 2 arguments, right? Because this is a C language function, and in C language you have to write every code, right? If there are number of lines or more, then you have to bunch in a function. That is the only difference between your algorithm and C function. In your exam they may ask you to write a program or write a function or write a algorithm, right? If the question is for write an algorithm, it will be for 4 marks. If the question is for write a program, it will be for 8 marks, and if there is a question for write a function, it will also be for only 4 marks, right? So just remember, memorizing these 5 steps, you will get 4 to 8 marks, right? So we will continue in this lecture. Insertion of the node in the end. This is very easy concept. Imagine there is a linked list in which you are having 2 to 3 nodes, right? Imagine you are having 1 minute. Imagine there is a linked list in which there are only 2 nodes, right? For the purpose of understanding, you take a linked list having only 2 nodes, right? The first node is pointing to the second node is now nodes, next is null. Now what we have to do in terms of insertion in the end of the linked list, we have to just create a new node whose next part will be null, and we have to just make sure that last node's next point is pointing to the newly created node. This null will be deleted automatically. Okay, okay. Now this is the concept to insert a new node in the beginning. The only thing is how you will reach to the last node. How you will reach to the last node. That is very easy to understand, because what happens to the in any linked list, the first node is pointed by head pointer. In any linked list, the first node is pointed by head pointer. Now head, with the help of this head pointer, you can see that up to head is equal to null. You can go move on, move on, move on, right? So in this case, what happens? Head is null? No, because head is pointing to this node. So move further. How to move further? By making see here, by making head is equal to head of next, right? So head will come here. So head is null? No. Head of next is null? Yes. If head of next is null, then you have to stop here, because this is the last node. You have reached to the last node. So whenever you reach the last node, just you make sure that this node's pointer of next will be pointing to this node. We will see in detail. See what you are seeing. The concept is insertion of a node in the end of the linked list. So following are the 6 steps are there. First step is allocate a new node. Very easy. Put the data in the node. Very easy. Then this new node is going to be the last node. So make the next of this node is as null. So right. So this is very easy. Now from 4, 5, 6, these are the 3 main steps, right? So step number 4, what it says? Step number 4 says that if the linked list is empty, then make the new node as a head. Obviously, if the linked list is empty, then this is the newly created node, and this is the first node in your linked list. So head should be pointing to this. Only this difference is there. Then case moving further. 5th step. If linked list is not empty, then you have to reach up to last. How to reach up to last? By using this while loop. By using this while loop. In this while loop, only one statement is there. That's why I have not written here opening curly bracket and closing curly bracket. As you are aware that in any block of statement, if there is only one statement, right? After while, after if, after for, if there is only one statement, then you can ignore the opening and closing curly brackets. Okay. Now what we are seeing? We are seeing the traversing to the last node, right? This concept we have seen in the print list function. How we have done the print list function? By making a pointer of next is not equal to null. In that case, it was n pointer. Now in this case, it is last pointer, because we are not moving the head itself, right? If head is moving, then everything will be disturbed. So head will be kept as it is. Head's pointer will be given to the last pointer, and last pointer will be move to the end of linked list, right? Imagine, I will, for the purpose of better understanding, I will take a linked list of 3 nodes. Now these are the 3 nodes, existing 3 nodes in the linked list, in which the last part will be null. This will be pointing to this, and this particularly first node will be pointing to second node, and this is your head node. Now what I have done, I have make a pointer L pointing to this node, right? So I am checking whether last of next is null. This is the next. It is pointing to another node, so it is not null. So what I will do, I will move last to the next node. How to move last to the next node? I will show you. In order to move the last to the next node, we have to just write a statement like this. Last is equal to last of next. So this is last of next. When this is pointing to this node, when you write a statement like this, last is equal to last of next, that means you are saying please last pointer you can move further to the next node. What you are saying? You are saying that please last pointer go to the next node, right? By writing a statement like this in C language, you are saying please last pointer move to the next node, right? So how long you will say last pointer please move to the next node? Until the last of next is null. That condition is achieved here when last is pointing to the last node of the linked list. The condition is last of next is null. Here the next pointer of the last is null. So this while loop breaks. So it will stop. When it will stop? When last is pointing to the exactly last node. Right? All of you are getting now. Now you already have a new node. Right? You already have a new node, and the next of new node is made null. Here in the step number 3 you have already made it null. Just make the pointers, that is last of next will be pointing to this node. After that what will be happen? This n will be removed and this last pointer will be pointing to there only. It doesn't make a difference, right? So in this way your linked list has got added a new node in the end of the linked list. So in this series of lectures we have seen how to insert a new node in the beginning in the earlier lecture, and in this lecture we have seen how to insert a new node after a specified or last node. Okay.